Now we'll discuss how the form of the first law of thermodynamics changes for various processes. So the first process is the isochoric process, and we know that for isochoric process the volume remains constant. Now according to the first law of thermodynamics, we know dq equals to du plus dw. Now for the isochoric process the volume is constant, therefore dv is 0. Therefore the work done dw equals to pdv is also equals to 0. Therefore, thus for the isochoric process, the first law of thermodynamics takes this form, that is dq equals to du. So now if dq is positive, that is plus dq, then du will also be positive, and if dq is negative, then du will also be negative. That is both the terms have to be either positive or negative. So if dq is positive, then it means that increase in internal energy, and if du is positive, if dq is positive, it means that absorption of heat. Okay, and if du is positive, it means that increase in internal energy. Okay, so for isochoric process, as dq equals to dw, then it means that the absorption of heat is entirely used to increase in internal energy. And if dq is negative, that is, it means that release of heat, okay, then du will also be negative. It means that there will be decrease in internal energy. So it means that for isochoric process, if there is release of heat from this system to the surrounding, then it will result in decrease in internal energy. Or you can say the decrease in internal energy for the isochoric process is entirely due to release of heat from the system into the surrounding. Next process is the isobaric process. So we know for the isobaric process the pressure is constant. Now according to the first law of thermodynamics, we know dq equals to du plus dw, and dq is du plus pdv. So for this isobaric process, here pressure is a constant quantity. So you can say that in isobaric process, the heat which is absorbed by the system is partly used to increase in internal energy, which is coming for this du term, and the rest of the heat which is absorbed is used to do external mechanical work due to increase in volume, which is coming for this pdv term. Okay, so for in case of absorption of heat for isobaric process, there will be increase in volume. But if there is release of heat, then there will be decrease of decrease in internal energy, and this work done will be negative. That is, there will be decrease in volume. Okay, so dv will be negative. The next process is the isothermal process. Okay, so for isothermal process, we know the temperature is constant. Okay, now according to the first law of thermodynamics, again we know dq equals to du plus dw. Now as temperature is constant, the internal energy E will be constant. Okay, because we know in general the internal energy is a function of this temperature. Okay, so if there is no change in temperature, then the change in internal energy will also be 0. That is, the internal energy is constant. So now as du is 0, the first law of thermodynamics takes this form dq equals to dw, as du is 0. So again you see as dq equals to dw, so we can say that if we have plus dq, that is, if we have heat absorbed by the system, then the dw will also be positive. Okay, so work done is positive, and we know in which case we take work done to be positive, if the work is done by the system. Okay, so if the external work is done by the system, then we take the work done to be positive. So for isothermal process, if heat is absorbed by the system, then it will be entirely used to do external work done by the system. But if the heat is released from the system during this isothermal process, that is minus dq, then dw will also have to be minus dw. Okay, so if heat is released by the system, then the work done will be negative. Negative means negative work done means work is done on the system by some external agent. Okay, so in the second case, if heat is released by the system, then the external work will be done on the system. Okay, so the first one matches with this one and the released one matches with the work done on the system. Okay, so if heat is absorbed by the system for isothermal process, then external work will be done by the system. Okay, and if heat is released by the system, then there will be external work done on the system. Okay, next is adiabatic process. So in case of adiabatic process, we know that heat absorbed or released is zero. That is, there is no exchange of heat between the system and the surrounding. So again, according to the first law of thermodynamics, we have this equation dq equals to du plus dw. Here dq equals to 0. Therefore, the equation takes this form: 0 on the left hand side, dq we have 0 equals to du plus dw, or du equals to minus dw. So you see here, this situation is slightly different from these two situations where either both the terms were positive or both the terms were negative. Now if one term is positive, then the other term has to be negative. So if we have plus du, then the work done will be negative. So plus du means increase in internal energy. So this one. So increase in internal energy. So if we have increase in internal energy, then the work done will be negative, means the work has to be done on the system by the surroundings. So external work will be done on the system. Okay, and if du is negative, that is, if there is decrease in internal energy, then the work done will be positive. That is, the work done work has to be done by the system. So if there is decrease in internal energy, then there will be external work done by the system. Okay, so the next process is this free expansion. Okay, so free expansion means the gas, suppose we have a gaseous system, is allowed to expand against vacuum. So the gas is expanding against vacuum means expanding against a pressure of 0. Okay, vacuum means it has pressure of 0. And there will be no exchange of heat during the free expansion. There will be no exchange of heat. That is, this dq term will also be 0. Okay, so these diagrams show the free expansion. Suppose we have these two boxes or vessels connected by this pipe-like structure. Okay, and there is some barrier. Okay, so in this first vessel, a gas is trapped. Okay, and the gas has some pressure P, volume V, and temperature T. Because of this barrier, the gas cannot enter this second vessel, which is vacuum. Okay, now if the barrier is taken out, then what will happen? Now the gas will expand from this first vessel to this second vessel. Now you see, this second vessel was vacuum. That is, the pressure over here was 0. So pressure was 0. So we can write pressure is 0. So now you see the gas is expanding against a pressure of 0. So it will, this is the phenomenon of the free expansion. Okay. So now, so what will be the form of the first law of thermodynamics for this free expansion? So again, the first law of thermodynamics is dq equals to du plus dw. Okay, or dq equals to du plus p dv. Now for the free expansion, dq is 0 because there is no exchange of heat. Okay, and p dv is also 0. The work done is also 0 because the gas is expanding against 0 pressure, against vacuum. So p dv term is also 0. Okay, so we have for the free expansion du equals to 0. Du equals to 0 means in case of a free expansion there will be no change in internal energy. Okay, So no change in internal energy means for an ideal gas there will be no change in temperature. Okay, because we know the ideal internal energy in general only depends on the temperature of the gas. That's why as there is no change in internal energy, there will be no change in temperature for real ideal gas. But for real gas, this situation will be different. Whenever there is a free expansion of real gas, some cooling effect can be seen. Okay. So for real gas there will be no change in ideal gas there will be no change in temperature, but for real gas there will be some cooling effect. That is, the temperature of the real gas will change for free expansion.